In example 10, it asks us to solve the triangle. Solve means get everything unknown, and everything unknown are angles. So we're going to use the law of cosines to get the first one because we need an angle. To do this. And one of the things that you have to be careful is, remember in the law of sines formula, we mentioned earlier that you don't know if it's acute or obtuse because it always gives you an acute angle on your calculator. This is where the law of cosines, when you want to get the angle and you do the arc cosine or the inverse cosine, it will give you angles from 0 to 180 degrees. And so we can get obtuse triangles when using the law of cosines, and this may or may not be obtuse. The key though is, and if you want to check if it's obtuse, we can do that. We learned that in the last chapter. So to check if it's obtuse, I'm going to use a squared plus b squared equals c squared. Okay? You don't have to do this step, but I'm going to tell you that this is an obtuse triangle because you take the two shorter sides, 6 squared plus 8 squared, and then you compare it to the longest side. That's 144. This is 36 plus 64. That's 100. This is 144. So since the c squared is bigger, we know it's obtuse. Now when you look at the angles, which angle looks like it might be obtuse? Well, it's probably angle C because it's across from the longest side. So remember, there can only be one obtuse angle in Euclidean geometry. And so we're going to use, we're going to do angle C first to get the obtuse angle. If we like, we can do some other stuff down the road and we'll talk about it as we get there. So I'm going to go back there, we'll do angle C, and remember there's different versions of the law of cosines. You only have to use one, but it's easier if it's already solved for cosine C. Equals a squared plus b squared minus c squared over 2ab. So remember, this was our example 8 solving for cosine C. So now we're going to take the arc cosine of both. So let's put numbers in to get cosine C. So I'm going to get, I'd like to call this, we'll just label our stuff here. This is A, this is B, this is little c. So if we label our stuff, we should be in good shape. And we'll get 6 squared plus 8 squared minus 12 squared all over 2 times 6 times 8. Now, since we worked over here and here, we know all these numbers really quickly, although they're not hard to do. 36 plus 64 minus 144 over 2 times 6 is 12. 12 times 8 is 96. If we simplify the top, we get negative 44 over 96. So we want to arc cosine that. So we're going to arc cosine both sides. And we're going to arc cosine that. So we're going to end up with C equals, so angle C is equal to the arc cosine of negative 44/96, and we'll type that on the calculator. So the measurement of angle C is 117.3 degrees approximately. Okay? So I'm going to write that in up here, 117.3, so we don't forget, because I'm going to have to erase some stuff here. So I'm going to erase this junk right here. So I have C. So if I can get one more angle, my life would be good. And some people want to do a law of cosines again, but it's kind of a lot of steps. So what I'm going to do is the law of sines, because I've already got rid of, I already know it's obtuse. I can just do the law of sines here. So since I have C, I'm going to go sine C over C equals, let's do sine B over B. So if we cross multiply this and this, and I'm trying to get B by itself, I'm just really going to I'm going to do all the work. I'm going to end up with this equation after all the work. Sine B equals B sine C all over little c. So sine B equals 8 times the sine of 117 point. So let me go back there to make that a little easier to read. 117.3 degrees over 12. And now the one thing is I've left this in the memory of the calculator, and so I'm going to use the answer key. So it's 117.02796.127 degrees, but I don't want to write all that out because it's not enough space here. So I'm going to get sine, well, back there, sine B, and I'm going to type these things in. So I get 0.5, it's a mess, I'm trying to fit too much in there, 0.5925. And again, I keep all the decimals in, but I'm going to write that because I'm showing my work. I'm going to take the arc sine of that. So I'm going to get B is the arc sine of this right here. I don't have room to write it in. Okay, so I type that in the calculator, second arc sine, second answer. The answer is listed above. And I'll get B is 36.3 degrees. So I've got this angle here, I've got this angle here. Over here, I should be able to finish off the problem here with the 180 rule. So 180 degrees minus 36.3 minus 117.3, and I get this final answer. I get the measurement of angle A is 26.4 degrees. So there's my third angle, and I said I was going to write them up there, so I'll go write them up there. So we get 26.4 degrees, and I get 36.3 degrees. Don't forget the decimal points there, they don't always show up. And I've done the problem.